Hi friends, I'm Mrs. R, your co-video substitute teacher for today, and I am ready for science. Now, there's a lot of cool things you can do in science, but a lot of it requires like special equipment we don't have at home. We talked about that before, how we have to figure out things that we might have at home or at least could get pretty cheaply because we're not at school. And when it comes to pretty cheaply, that means it doesn't cost much money to get those supplies. And because there are two reasons. One, your parents are not supposed to be going out shopping every day. We need to watch how much we go out in public. Remember, we called that social distancing. That's social being around people, except at a distance. We have to be farther away. And for some people, we might need to stay home even more than that. But also, mom and dad and everybody else who helps bring money into your family, if they're like me, they're not working right now. So we're not bringing in any money. We're having to watch our money a little closer than we're used to. It's okay. We'll all still get through it. Well, there are things out there to make sure we don't starve and we don't get our electric turned off and stuff. There are things to help us with that right now. But it does mean we have to think about what kind of supplies we have. So once again, you're going to need paper. Go and get 3 to 4 pieces of paper, okay? At least 2. Here's why I'd like 3, even better. You'll need 2 for our scientific experiment. But no scientific experiment is worth anything if you don't do the science part of the scientific experiment. And there's actually a word we use for this. It's called the scientific method. Method means the way you do a thing. Scientific means you do it with science. So this is something where we use science to make the way we do it. And there's a very particular way that's led out. And for scientific method, number 1 is actually super easy. Ask a question. I mean, you could do experiments just to watch stuff experiment out there, but you won't learn from that. Science doesn't learn from that. Science needs a question. You have to figure out a question to ask. And then when you make up your question, you then need, and I'm going to hold this up, pause it to read this word, make a hypothesis. What's a crazy word? Hypothesis. It means guess. Yeah, like why they used a super huge word just to say guess, I don't know. It's because it's scientific, I think. But yeah, it just means guess. So you have to make a question, and then you have to guess at the answer. And then that's why you do the experiment, to see if your guess is right or wrong. And sometimes your guess is both kind of right and kind of wrong at the same time. But that's what we're going to do. So those are our first. Ask a question, make a hypothesis, make an experiment. Now, you remember I said to get some paper. Your experiment is going to use paper, so you'll need those supplies. If you don't have, like I said, this isn't even regular notebook paper, but whatever rectangle of paper you can find will work. If you have to use something a little more square, you'll just have a slightly different experiment, and you'll be able to know science that the rest of us don't know because your science is different. That'll be really cool. But we need to write down our answers, because otherwise, if you just tell me a thing, like, yeah, no, I'm pretty sure it's true. That's still just your guess. That's not an experiment. We have to collect data, collect evidence. How do you get evidence? You do the experiment. So today, our experiment is paper airplanes. Most of us already know how to do a paper airplane. If you don't, I'm going to show you. But if I throw out the paper airplane, it sails out, it flies a little bit, but it's going to crash, right? Sometimes they crash super fast. They go like this. Sometimes they start spinning in midair. Right? It's really weird. So my question, though, is if I look at a regular paper airplane, what if I made the nose longer and pointier? Will that make it fly better? So my question, ask a question. Does a pointy nose fly better, right? So we're writing that down. Does a pointy nose, that's, by the way, we call the front of an airplane a nose. Pointy nose fly better. Now, in this case, we're going to say better means farther. Sometimes better might mean higher, but with paper airplanes, we're kind of just throwing them out, so it doesn't matter. Now, make a hypothesis. What's my guess? Does a pointy nose make it fly better? I'm going to guess yes. Maybe you're guessing no. Are you guessing no? It's cool. We don't know which one of us is right yet, right? So I'm going to say yes. I even put a little exclamation point. Yes. Make an experiment. So first, what you need to do is make a paper airplane. So if you've never known how to do that before, here it comes. You need a piece of paper that's in a vaguely rectangular form. Now, we're going to fold these front corners down. So when we do that, you want to bring both of them in until they meet in the middle, hopefully as even as possible, because we don't want our airplane to be super lopsided, right? So mine folded like this. It is a little crooked, but I think it's going to be okay. The next thing you do is, starting with that point, and you have like the lines between these pieces of paper, use that to fold it in half. There we go. Now, bend this corner down. Do you see how I'm bending this? And I'm going to just come down right to the same point where the bottom of my airplane is. See, I just brought it right there. And then I flatten this out. And we'll make the other side match. So I'm going to take it down the other way. And then put your fingers here to open those wings back out. Here we go. You can throw it now. It actually just kind of went over there and crashed. It's a little sad. But I do know how it flies. I'm going to do it several times. Let's say 5 times maybe. So I pick another one up. That's right, I just had another one. If you have more than one piece of paper, you can make more. But you want to go pick that one up, really, that one over there, and throw it again. Because we want what we call consistency in our variables. That's crazy, isn't it? That was so many big things. Consistency means the sameness. I want the sameness in my variable. Variable means things that can change. So I want to have the sameness in the things that can change. If I switch to another airplane, that's a thing that changes. And I don't want to change it. I want to use the same one. So let's throw it 5 times. And as we throw it, pretty good that time. Look at it this time. Let's see if it does a little better this time. It actually did worse. Well, at least I know. But what I need to know now is we change a variable. That means we change a thing that can be changed. In this case, with all scientific experiments, it has to match a question, right? Our question was, will a pointier nose make it fly better? So let's start with making our paper airplane again. Let's fold those first 2 corners in. We got that? But look what I'm going to do now. Instead of folding it in half like we did the other one, I'm going to do a whole nother step first. I'm going to bring this corner into the middle. Look how much longer and pointier this side is than this side. This was our old style. This is going to be our new style. So we have to do the same here. So we bring this one in. And I very carefully flatten that fold back out. It has a much longer, pointier nose. Now the other steps are going to be the same. I'm going to fold it in half this way. So these foldy parts are on the inside, right? See that? And then I fold these down. I'm gonna start my wing right about here, I think. You do yours best you can. Figure out how you want it. So it's gonna meet the bottom, right along the bottom. See? It's even on the bottom there. So like that. And I do the other side the same way. So now that seam from the top, and the side, longer, pointier nose. Now what I need to know is, will this fly better than my other one did? And we need to do the same number of tries. We're going to do 5 tries with it. So you would start it off. Wow. Maybe I just threw that one better. We'll try 4 more times. Be right back. I actually just ducked over. Okay, I'll actually be right back. I'll go get it. So, we're going to go get it. Did you guys get yours? Okay. We ready? Try it again. Three more times? We had 5 that we needed to do. We sailed it once. We sailed it again. 3 more times. 1, 2, 3. Do that. Now, every time you did it, you need to be writing it down, right? So we had our first one, and it only went over there. Pick something that it's near. You can lay a book down by it or something else or a toy. And I'm going to say it went to my toy. My first airplane went to the toy. We'll say 4 times. See, I made 1, 2, 3, 4 marks. One time, didn't even go that far. I'm going to make a mark here. Not far. Now, we did our second one, and we threw it. And I'm going to say, yep, went to the toy again. Every time I did it, it went to the toy. 5 times. Question is, though, did it go farther? And yes, mine did. Mine actually went all the way underneath my bed. I don't know. I got to get it out. I got to crawl under the bed, or maybe I get my dog to do it. But whatever it was, it went farther. It went farther 1, 2, 3 times. Went farther. Went all the way underneath my bed. Went under my bed. That was definitely farther. I wrote my answers down, so I have them. So now let's go back. We made an experiment. We tested our nose, right? Sounds funny. Tested its nose. We changed a variable, the nose. What did the data say? The data, what the word data means is your information, your evidence, the things that happened. And we said that. And what did the data say? It went farther. So, was your hypothesis right? Hypothesis is that big word that means guess. Actually, I guessed right? I can look up here, make a hypothesis. Yes, I wrote yes. And it did go farther. Yes. Yes. My scientific airplane experiment says the pointier nose went farther. That was pretty fun. Next time, though, let's change something else. Maybe I'll put tape on the front end and see if that tape would make it a little heavier. And maybe that'll make it kind of, no, I don't want it to dive bomb. Maybe I'll put the tape on the wings. Maybe I have paper clips I could stick on it. Those would be other variables, things you can change. And then you record, throw it 5 times. When I throw an airplane with tape on it 5 times, does it go farther or shorter? Twice it went farther, 3 times it went shorter, then that means 3 times it didn't do it. That means that didn't work. But now you can start making paper airplanes. And if somebody in your house says, why are you throwing paper airplanes from my house? You say, oh, science.